This is Abdulkarim again, and today we're going to be continuing our Matlab video series. So, in the last video, we discussed about some functions that were built in. For example, this rounding operations. We figured out what round and floor seal functions are, and we're going to first continue some more built-in functions. For example, we have this vector that I just created. You can see here the values of it, and you can see that it's only one row. So the first one is the minimum. We can we can check the minimum value of some vector and the maximum value and the mean and the product value, and we can also sort it from ascending order or descending order. This is uh, mainly useful for statistics majors. So, uh, for the first example, we're gonna see minimum if let's do it in our minds. For example, the minimum if here we can see that it's minus 8.3. The maximum will be 10, and the mean and the product will just let it calculate it itself. So let's run this code and see how it goes. So, as we can see here, we have here our vector f. Our max value, we can see that it's 10. The mean value, it's 1.9250. You can also check it by the calculator. The minimum value, which is minus 8.3. The product value, it's very big. It's minus 1.34 uh, multiplied by 10 to the power of 6. And this is the sorted if. We can see here, this is the sorted version of f, and this is the decent sorted version of f. So if I wanted to make it ascending sorting, I'm just gonna type sort if and finish it that way. But if I wanted it to be decent, all I have to do is to type sort if and then comma and then type the word decent, and then it's gonna be in a decent order. We're gonna see like now. So if I type sorted if, it's we're gonna see that's uh, in a ascending order. However, if I wrote the decent, it's gonna be from the larger number to the smaller number. Another thing that is worth mentioning, which is um, finding the max value or minimum value or even the mean value for that, etc. for a matrix. So we're gonna go back to our M1 matrix, for example. Here, I'm gonna run it. So I'm gonna have it here as 1, 2, 3, 4, 5, 6, 7, 8, 9. And if, for example, if I wanted to get the maximum value of the first row, so it's between 1 and 4 and 7. I'm sorry, 1, 2, and 3. The maximum value of this is 3. So all I have to do is max and then put our matrix M1, then put new parentheses. Now I'm gonna type the number of row. So I chose the first row, so it's gonna be the first row, and put a comma, and I want it to be in all the columns, so I have to write semicolons, close the parentheses, close the second parentheses, and we're gonna have it here as 3. Another example where I'm gonna show, for example, uh, the second column, for example, I'm gonna get the mean of the second column, which is 2, 5, and 8, which is gonna be uh, 5, I think. So I'm gonna type mean M1 and open new parenthesis. So I'm gonna choose from all the rows. So I'm gonna put semicolons, then the second column, and as we can see, it's 5. We're gonna move now to a new topic. Uh, in context of MATLAB, which is figures and plotting the figures. So, as we all know that every figure or every graph or every function has its x value and has its y values. So that's why we have to define first of all the x values and the y values. For the x values, I'm gonna use the line space function, which as we can recall, it's gonna be starting from 0 and it's gonna be ending by 2 pi. And there's gonna be 100 points or 100 steps between these two values. And for this x values, we're gonna compute the y values for it. So this is my function name that I'm gonna use, y underscore sine, and this is our function that we're gonna use, sine x. So for every value here in the line space, it's gonna be substituted here in the sine x, and it's gonna be plotted. So how are we gonna plot the figure? First of all, we have to type the uh, this function as figure and put our semicolon. And as we're gonna see here, the figure open a new figure window. So uh, how are we gonna start plotting? All we have to do is just type plots and then open a parenthesis. Then we're gonna start by the x value. So in our case, the x values or the domain of it is just x. So it's gonna understand that this line space is here. And the y values, it's gonna be the y sign, which is the sign of the x values. And this is some expressions just in order to see the plot or graph in a much better way. So in this case, this is G. It means green, and this is our line width, which is gonna be 5. And all of this we can edit it, and we're gonna see now. And of course the marker size, which is uh, the size of each dot or each point that we're gonna be using. Uh, we marked it here as 10. Then we're gonna be adding the grid on the grid, which is the squares behind the graph. And of course, we have to make it easy to demonstrate the graph. So we're gonna be adding the x label and y labels. Uh, just to define the x labels, we have to x label and type whatever we want, uh, either x values. In the y label, I'm gonna type function values, and for the title, I'm gonna be using sine function. Now I'm gonna run this code to understand even better. F9. So here's our graph. As we can see here, it started from 0. It's ended with 2 pi, which is 6.28. And the y values are just the sine values of these x values. And as we can see here, it's a green color. It's in a green color. It's the marker size. As we can see here, the circle is is so big. Uh, we can also edit the circle, use another type, uh, and we can check. Here we have all the specifiers for color symbols and line spaces types. Um, these are our colors, these are our symbols, and these are our line types. We're not obligated to use anything. We can not use it, and we can also use it to make it even better. So, for example, I'm gonna edit the our code. So I'm gonna use the point, and I'm gonna use the color blue, and I'm gonna use the solid one. So all I have to do is uh, for this color, I'm gonna edit it as blue. For this, I'm gonna edit it as dash, and for the points, I'm gonna just type point. So let's run this code. As we can see here, these are the points. But of course, we cannot see it because it's points, and the type of our line is a dashed line. Let's use another example. Let's use the x, for example. So I'm gonna just type X here and I'm gonna rerun this code. So now it's much obvious how is the X value, how is X plots are used. In plotting figures, we can also use another function on the same graph. For example, let's say I'm gonna use the cosine function. So let's first of all define the cosine function. So I'm gonna type cosine x, and then I'm gonna, in order to keep the plot as it is, I have to type hold on. So because I'm gonna use it, I'm gonna use the same graph but with a different plot. Now let's plot the function. It's gonna be the same for this, except that this is gonna be a cosine function, and I'm gonna also get rid of that to not get confused. I'm gonna use this circle, and I'm gonna use for this, um, let's say the color gradient again. So now I'm gonna just change the title. Let's make it sine and cosine function. Let's run this code. And I'm gonna use the circles example. Let's run this code. So we can see here that we have the two functions. This is our cosine function, which is the green one, and our blue one, which is the sine function. They all have the same x values from 0 to 2 pi, and all have the same y values from -1 to 1. Yeah. So what if we wanted to draw these two functions on separate plots? So I don't want it on the same plots. All I have to do is use subplots. So for the first function, I'm gonna just type here subplot and open a parenthesis. And this is our number of rows, 2, number of columns, 1, and this is our order for this function, 1. So in this order, it's gonna be dividing the screen into two rows and one columns, and this is our first function that it's gonna be starting with, our sine function. And since now we're gonna use different labels and different titles, then I'm gonna remove this, and this is gonna be for our sine function, which in order we have to do to make it like this before our second plot. So, so for our second plot, we're gonna use the same thing here. The only difference is that this is gonna be our second function, so I'm gonna have to type here 2. And of course, let's use another x labels, y labels, and of course we're gonna use another x and y label, another title for the second plot. So let's here, this is gonna be our cosine function. So um, and let's not forget our grid. We can also use another function which is called legend. And to finish, we have to type hold off just to allow new plots in the future commands. Now let's see how our subplots are. Gonna run this. So as we can see here, these are two rows and one column. Our first function was the sine function, and our second function is the cosine functions. We have here our x labels and y labels, and we have our titles here. We have our grid here, so everything is good and clear. Okay, so moving to a very new topic in Matlab, which is accessible files and function files, script files, all of these. The most common way to operate MATLAB is by entering commands one at a time on the command window. The M files provide an alternative way of performing the operations that are greatly expanded by uh, the MATLAB's problem-solving capabilities. An M file consists of a series of statements that can be run all at once. And mostly M files come in two flavors. It's either script files or function files. Let's start with the script files. As we can see here, this is a mathematical or physical formula to calculate the velocity when we have our gravitational constant, mass, time, and drag coefficient. So all I have to do here is just save the file as, for example, let's name it here as it's here demo. So I'm gonna type demo, and I'm gonna use the same one. So this file is gonna be called demo. So whenever I call this demo file, demo script file, all what he's gonna do is calculate this velocity. So let's check here. I'm gonna type demo, and it's gonna be calculating the velocity uh, automatically, which is 50.6175. And I can use this script file in any window. Uh, so this is just a developed script file to build the velocity of a free falling jumper for the case where the initial velocity is 0. Now let's move on to the next topic, which is function files. Now we're gonna move to the next topic, which is function files. So if I have a function, uh, although if I wanted to make a function, I have to type function, and this our is our output. So velocity is our output. This is our function name. I'm gonna type it as velocity, and these are our inputs. So for this output, in order to get this output velocity, I have to uh, give the inputs as initial velocity, acceleration, and time. So, and for this velocity output, we're gonna add the formula. That's the program I'm gonna use. For in this case, I'm gonna type velocity is equal to initial velocity plus acceleration multiplied by time. We all know this formula from physics. So, and we're gonna end it right here. So, how are we gonna use it? Well, just you have to save as, and you're gonna save. I'm gonna type yes. So this is my function for velocity. So if I wanted to give uh, specific values for initial velocity, acceleration, and time, all I have to do is go to the command window. Initial velocity, I'm gonna assign it as v naught. Let's assign it as, for example, 3. And the acceleration, I'm gonna use it as 4. And the time, let's assign it as 5. So now we have all our inputs ready. So we have now to call our function. Uh, I have to do, I have to copy this file name or this function name. I'm gonna type it here, and then we're gonna use the order that we used here. So in initial velocity, it's gonna be v naught. Then we're gonna use acceleration, and then time. Let's close our parentheses, and this is our answer. Can also retype it as velocity, and I'm gonna put the numbers directly without needing to put the variables, assigning the variables before. So it's gonna be the same answer, 23. And someone now might ask, what if I wanted to use a function in this same function? So I'm gonna use the velocity as as an input for another output that I'm gonna be using. For example, if I wanted to find the distance here, um, so we have our first output, which is velocity, and I'm gonna be adding the next output, which is distance. Just type distance, and I'm gonna be adding its formula right here. It's gonna be distance. This. Okay, so that means that this is what the distance function gonna use from the variables. Let's move on now to typing the sub function for this function. So I'm gonna type function. I'm gonna type d, and I'm gonna type the distance, the name of the function, and it's gonna be between v nodes, our inputs a and t. But we have first to define the formula that's the code gonna use, which is in this case gonna be in the case of velocity, it's gonna be v equals to v naught plus a times t, and for the d, it's gonna be v, which is the velocity, the first output, the final velocity multiplied by t, and I'm gonna amplify. So now we have our function file here ready. All what I have to do is just to use it. So first of all, I'm gonna save it. I don't have to use save as again. I'm just gonna save it. So now it's changed. And now we're gonna move to a whole new editor file. Let's just type our variables. Now it's gonna be v naught equals to, gonna say it's 2.5, and for a it's gonna be 4, and for t it's gonna be 5.2, for example. Now we're gonna call our function. So just add our uh, first of all, we're gonna put the outputs that we're gonna be using. So for the outputs, I'm gonna be using the brackets, and we're gonna be using the just v and d. Sorry, v and d, and it's gonna be equal to the file name, which is velocity, and we're gonna be putting our parentheses. After that, we're gonna put our inputs here. So v naught, and as we can see here, that it's already assigned as initial velocity, a acceleration, and time. So we're gonna run this code right now. So as we can see here, it used our function here. It gets our output as v and d. Our v here is 23.3, and our d is 121.16.